All right. Our objective for today, I can convert fractions to decimal. Let's read together. 1, 2, 3. I can convert fractions to decimals. So today's concept is fractions and decimals, right? And those are called something specific. We covered that when we covered real numbers the other day. I think it was like 2 weeks ago. So today we're going to be revisiting rational numbers, okay? So in your Freyer model, let's write the rational numbers. But before we do, I'm going to ask you a question, and at the end we'll answer this question. It says, what is the difference between a terminating decimal and a repeating decimal? So, rational numbers. Write this down, please. It says, any number that can be written as a fraction where the numerator and the denominator are integers and the denominator cannot equal 0. Copy that. Examples. 3/4, 7/5, 0.25, 1/3, 9/6, 5.4, 7, and -8. All those are examples of rational numbers. Copy that, please. All right? Okay, let me go over this according to the definition, and then I'll let you finish copying in a little bit. Pens down, eyes up here. Pay attention, please. Here it goes. It says, rational numbers, any number that can be written as a fraction. Okay, is this a fraction? Yes, 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 and yes. So far, so good? Fractions. However, it says any number that can be written as a fraction. -8, could it be written as a fraction? Yes, by putting what? Over 1. Oops, sorry. Zoom out. Over 1. Is that a fraction? Yes. Yes. So far, so good? Look at this one, though. Who remembers how to do this one? We put that, let me show you. Here it goes. I'm going to refresh in your memory. 0.25 is the same as 25 over 100. Yes? Is it a fraction? Yes. How about this one? 5 and 4 over 10. Is it a fraction? Yes. Are we there so far? Okay. Now, these are rationals. Let me show you non-examples. Let me show you what is not a rational. So according to the definition, all these are rationals because they can be written as a fraction. The numerator and denominator are integers, and the denominator cannot equal to 0. So here's non-examples. Copy these. And as you're copying them, start thinking, if these are rationals, why are these not rationals? All right, talk it over with your neighbors. Why are these not rational numbers? All right, let's see. Who saw that the definition says denominator cannot equal 0? Did anybody see that? And here we have the denominator of 0. Do you guys see that? That's why this is not a rational. However, why is this not a rational number? Because it's not just a number. This is a what? It's a problem, yes. But when it has this, what is it called? You're right. When it has this, it's called an equation. And right now we're not looking at equation. We're just looking at rational numbers. Does everybody understand? So, critical attributes. Write this down, please. They are numbers written as a fraction. They are integers. no zero denominator, and they are numerical expressions, not equations, just numerical expressions. Copy that, please. So, steps. Write these down, please, underneath your prayer motto. It says, to convert a fraction into a decimal, number 1, identify if the result is a positive or negative. Didn't we see that already? Yeah, right? Step 2, compute the numbers, which is divide. Didn't we see that already also? Yes. But look what's different. Look at step 3. Identify if it's a terminating or repeating decimal. That one's new, right? And the last one is the same. Simplify. Copy that. So, we got the steps. So, if you notice, the steps are the same as the previous days. Is that correct? Except for step 3 is a new one, where we have to name whether it's a terminating or repeating decimal. So, with that said, just to recap, terminating and repeating decimals. Terminating decimals are decimals that there are no leftover after you do a division. Okay? Terminating decimals is when there's no leftover and it stops. So, for example, here it goes. 0.25 is terminating because it stops. You don't have to copy this. Just pay attention. How about 0.30? Is it terminating? Yes, because it doesn't continue. However, how about this one? 0.333333333, and it continues. That's what we call what? Repeating. And if we call it repeating, then we need to write it like this. 0.3 bar. Remember that? This is more like a review of what we've seen in the past, right? How about if we have this? 0.278, 278, 278, 278, dot, dot, dot. That means this becomes 0.278 with a bar on all 3 numbers so that we know that it repeats again. Is that correct? All right. So once again, terminating, they stop. Repeating, they continue. Okay? So with that said, example number 1. Copy these 2, and then we're going to do this one together. It says, write the fraction as a decimal. A, 11/9, B, 7/20. A, 11/9, B, 7/20. Copy that, and I'll go over these. Now, check this out. I'm going to go over this one more time because I still see some of you struggling as to where each one of these goes. Pay attention, please. Here it goes. Let's see. Who's played with this before? Let me show you really quick. Look up. Hold on, give me a second. Mr. Q. So, that's 1. Who's played with wood blocks before? The blocks made out of wood? No, wood blocks. Okay? All right, here we go. So watch. And you did anybody stack them before? Something like this? Huh? Thank you. So do you see how there's 3 blocks stacked one on top of the other, right? Now, I don't know about you, but in the past, I had little cousins that they were like, my goodness, they bugged. Enfadosos. So sometimes I was playing like with whatever. Let's say I'm playing over here with, I'm doing a drawing, and guess what they would come and do? It's coming out really nice, and I'm focused, and guess what? They come, and they go running like, ha, 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 ha. Oh. So I'm here, I'm playing with my wood blocks. Guess what they're going to do?
Knock it over.
Knock it over, right? Is it only me, or do you guys have little cousins like that? So you're like, no? Well, if you don't, then you're probably that cousin. Anyways, here we go. So check this out. Let's say we're playing with wood blocks. Pay attention. And I'm going to make this fraction with these wood blocks. Here's the number 11. The fraction bar is right here. And this one is a 9. Because, you know, I was in kindergarten and I already saw fractions. I was like, hey. So anyway, so here comes my little cousin. And then they push it like this. So it's going to fall. Is that correct? Which number lands way over here? 11. What block lands right next to it?
9.
No, next to it. The division bar, right? Like this. Sideways. And what is the only one that scoots over a little bit? The 9. Well, guess what? That's how you know how to write your division. Boom! That just... Bam! That just happened. The reason I'm going over this because some of you still get confused which number goes inside. Will that be easy to remember? So now just think about your little cousin. My goodness. Mom, I'm going to go out and play with my friends. Take your cousin. Oh my goodness. Really? Did that ever happen to you guys? Oh my goodness. All right, here we go. So let's do this one together. Write it out, please. Does 9 fit into 11? One time. Draw the 9. Subtract. 11 minus 9, that is 2. All right? From there, is there another number here? No, so we add a decimal, 0, decimal, and we bring the 0 down. 9 fits into 20 how many times? 2. You write that in here. That is 18. Subtract, that's 2. And what do you guys notice? It's going to start repeating. So if I bring this down, it's 20 again. That means this is going to be 2. So check this out. This is called repeating decimal. Write that in there, please. Whenever it's repeating, this is what I want you to do. I want you to write here the wiggles. Wiggle, wiggle, wiggle. Everybody see that? Why? Because it's not exactly equal. Is that correct? It's approximately, aproximadamente, it's approximately 1.2 bar. Does that make sense? If it repeats, might as well just write once and then put the bar on top of it. Okay, let's do B. Let's see, which one goes at the end? 7, and then the bar, and then 20, and you do your division. There it is. All right, here we go. Does 20 fit into 7? Put 0, add a decimal, decimal, 0. How many times does 20 fit into 70? 3. That's 60. Subtract. That leaves us with 10. Add a 0. Bring that down. 20 fits into 100 how many times? 5. And that is... Do we have any left over? Is this repeating? This is called terminating. Terminating decimal. Okay? I'll be back, yes? All right, so check this out. So when it's terminating, look up, please. Let me move this down a little bit. When it's terminating, here we do write equal to 0.35. 5. Do you see the difference? Approximately equal. Approximately equal, yes.
So what I do, like for example, 7 over 20,
Yes.
I multiply it, well, it depends. If the denominator
To make it 100? Right.
That's 100.
Right. For right now, we're just trying to do the long division just to practice. Any questions with this? All right, I'm going to send you the screen of the next one. You're going to do this one by yourself. This one, I want you to do on your iPad. So copy that. Let's see, Brian, as people are finishing up, tell me to do C, please. Brian? Okay. So which one, what do I write? 9 is outside the box. So if your cousin comes and drops it like this, which one goes farthest to the right? The 15, that goes in the box. So, does 9 fit in here? How many times? 1, subtract, that's 6. Are there any other left over? No, put a decimal. Decimal, bring down the 0. How many times does 9 fit into? 6, 54, and we're left over with? And what do you notice? Keeps repeating. So this is called a repeating decimal. So what do we write here? Approximate, or the wiggles, wiggle, 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 1.6 and bar. Hands, have you got that? Bam! So let's go over letter D. Help me with this one, Anissa. Which one goes inside? The 9 divided by 40. Does 40 fit into 9?
No.
No. Add a decimal. 40 fit into 90.
Yes.
How many times?
2.
2. That's 80. Subtract, that's 10. There's no more digits, so bring down the 0. That becomes 100. If it's in there, 2. 80, subtract, that's 20. Bring another 0 down. If it's in there.
Oh, I didn't do that.
Okay, that's fine. How many times does 40 fit into 200?
5.
5. 200. Do we have any left over? Therefore, this is a terminating decimal. And what do we write here?
0.225.
Equal, right?
Yeah.
Equal 0.225. Hands, have you got that? That is correct. Any questions? Fairly simple, right?
Yeah.
So now check this out. We're going to do this now with word problems. Here he goes.
Pizza.
Boom. It says, Mr. Q orders pizza for his period 3 class. Look at the picture. Wait, I still have the next problem's for you guys. Relax, my goodness. Look at the picture and write fractions of the pizza left for the students after Mr. Q sends some slices to the office staff. Convert the fraction into decimal. So first of all, let's see. Check this out. How many whole pizzas do we have left? 1, 2, 8. Okay, let me write that out. 8. 1, 2, 3, 4, 5, 6, 7, 8. And how many slices are left here? 1, 2, 3, 4, 5 out of what?
6.
So this is 5, 6. Are we there so far? So now check this out. We need to change this into decimal. So that means we write this one right here, 8, and then we're waiting for the decimal, right? So do we know how to write this as decimal? Yeah, 5 divided by 6. Does 6 fit into 5? No. Into 50?
Yes.
Yes. 8 times, 48, subtract 2, add a 0. Into 20, 3, that's 18, subtract, that's 2, another 0. And what do you notice? it repeats, so it's 8.3 bar. So this is 8.83 bar. Fairly simple? Yeah? Do this next one, please, by yourself. Here it goes. Yeah, on the iPad. So I'm going to send that over. So example 2Q, it says, Mr. Q orders sodas for his 7th period class. Look at the picture and write fractions of the soda left for the students after Mr. Q sent home soda to the office staff. Said to the office, my bad, not home. Convert the fraction into decimal. Now check this out. So that you don't get confused, look up. This is 1 part, 2 parts, 3 parts, 4 parts, 5 parts. Does everybody see that?
Yeah.
So what would be our decimal for this? Everyone. Let's see, help me out. 6 and what? Oh, let me go back. 6 and 1/5. So now here, all we have to do is write 6 and to convert this. Is that correct?
Yeah.
So this becomes 1 divided by 5. It doesn't fit. Does 5 fit into 10? 2. And we're done. So it's 6.2. Once again, our home plate for tonight is going to be on page 64. I'm going to upload the video right now so you can have it available in case you want to see it at home. Make it a movie night with your parents. Bye, guys. Have a good one. See you guys tomorrow.